Hello everyone, welcome back to my channel. Today we are starting Unit 2 of Software Architecture as per the RGPV syllabus. In this unit, we will be learning about software architecture models, structure, framework, dynamics, and process models and different architecture styles like data flow, pipes and filters, layers, agent based, and many more. Let's begin. Software architecture models are basically different types to represent structure and behavior of a software system. They help developers visualize, document, and communicate how the software works internally. Structural model Structure model focus on the static structure of a software system. They show component, classes, and relationships, but not how they change over time. Some common types including class diagram show classes, attributes, and their relationships. Component diagram shows major software components and their interactions. Package diagram groups related elements logically. Deployment diagram shows how software components are deployed on hardware nodes. Object diagram a snapshot of objects and relationship at a specific time. Purpose to understand how different parts of the system fit together structurally. Framework models. Framework models provide ready made structures or templates to simplify development. They help developers save time by using pre built tools and reusable code. Some common examples: Web Framework, Django, Lavarange, ASP.NET, Ruby on Rails, Frontend frameworks, React, Angular, Vue.js. Backend framework Express.js, Spring Boot, Flask, mobile framework Flutter, React Native, and testing frameworks JUnit, Selenium, Jest. Enterprise framework Java, .NET Core. In short, frameworks give you a base structure so you don't have to start from scratch. Dynamic models. Dynamic models describe the runtime behavior of a system, how components interact, respond to events, and change states over time. Common examples: sequence diagram shows order of interactions between components. State machine diagram shows how an object transition between states. Activity diagram shows the flow of action or process. Collaboration diagram shows communication between objects. Timing diagram shows timing and duration of event. Purpose to understand how the system behaves dynamically when running. Process model. Process model describe how software is developed step by step. The life cycle or approach a team follows. Common model includes waterfall model, linear and sequential, one phase at a time. Agile model, interactive and flexible, adapt to user feedback. Spiral model, risk based and iterative, combines design plus testing cycle. V shape, focus on testing at every stage. Incremental model, develops the software in small part on or versions. Red model, rapid application development, quick prototype plus feedback. DevOps model, integrates development and operations for fast delivery. Goal to ensure the software is developed efficiently and systematically. Software architecture style. Software architecture styles defines how the system's components are organized and communicates. Let's look at some popular ones. Data flow architecture. Here, data moves through different process nodes. Each components perform operations as soon as data arrives. There are two types: static data, fixed structure at design time; dynamic data. Structure can change during runtime. Used in signal processing, data pipeline, multimedia apps. Second, pipeline and filter architecture. This architecture is like a data pipeline. Each filter perform a task like sorting or filtering, and pipes pass data from one filter to another. Used in Data transformation, compilers, and image processing. Advantages: modular, reusable, scalable, and easy to debug. Third, call and return architecture, a basic structure used in most programming languages. Functions or method call other functions and return result. Example: function call in Java, C or Python. Advantage: promotes modular design and code reuse. Layered architecture. The system is divided into multiple layers, each responsible for a specific task. Common layers: presentation layer, user interface; application layer, business logic; domain layer, data structure and rules; data access layer, database operator. Used in web, desktop, and enterprise application. Advantage: easy maintenance and scalability. Fifth, data centered architecture. Here, data is the central focus. All components access and update a shared data repository like a database. Used in database system, data warehouse, analytics platform. Advantages: consistency, flexibility, and maintainability. 6. Agent based architecture. The system is made of autonomous agents that interact and cooperate. Each agent has its own knowledge, behavior, and goal. Used in AI systems, simultaneous robotics, and distributed control systems. Advantage: adaptability, flexibility, and real world models. Microservice architecture. The application is divided into small independent services, each responsible for one features or business functions. Used in large scale web apps like Amazon, Netflix, and many more. Advantages: scalability, independent deployment, flexibility. Challenges: data consistency and service coordination. 8. Reactive architecture. Focus on building responsive, resilience, and message driven system. It handles real time data and a high number of users efficiently. Used in IoT, streaming platforms, trading apps, and gaming. Core applications: responsiveness, resilience, elasticity, and message driven communication. REST architecture, representational state transfer, used for web services and APIs. Each resource is identified by a URI and accessed using stand HTTP method: get, post, put, delete. Used in web and mobile backend systems. Advantage: simplicity, scalability, and loose coupling. That's all for Unit 2, Software Architecture Models and Styles. If this video helped you understand the concept better, don't forget to like, share, and subscribe for more. See you in the next video.